Hi, in this video we are going to talk about applications of tree data structure. The first application is they are used to represent hierarchical data. Whenever you want to represent hierarchical data in memory, you want to store hierarchical data in memory, you use tree data structure. For example, organization structure. You have main person at the top, then people reporting to him, then people reporting to the reportees, and so on. You represent such a structure using tree. Folder structure. In operating systems, you have folder structure. For example, in Linux, you have root and then subfolders inside it and then subfolders inside them. You use a tree data structure to represent folder structure. XML and HTML content. When we read HTML content from a page, it's read as a tree. You have HTML tag at the top, then it has children tag like body and head, and they have their own children tag. So whenever you have nesting of tags, you use tree to store such a structure. JavaScript in browsers reads your HTML page as a tree and then can manipulate this tree. Basically, it manipulates your page using this tree structure. XML data is also a tree structure. In object-oriented programming, we see trees many places. For example, inheritance. You have the base class, then their children class and their children class. This is also a tree. Other applications of tree, and the most important application of tree is binary search tree. We will cover binary search tree separately, applications of binary search tree separately, so I'm skipping it here. The next application is binary heap. Binary heap also we'll cover separately. Binary heap is mainly used to represent priority queues, and priority queues are useful in Dijkstra's algorithm, Huffman algorithm, Prim's algorithm, or any other place wherever you need a queue with priority. B and B plus trees in databases. B and B plus trees are used in many databases for indexing. So if you want to implement indexing, you have two choices. Either you use B or B plus trees or you use hashing. And B and B plus trees are really common in databases. In computer networks, we have spanning and shortest path trees. These trees are used in devices like bridges and routers respectively. Bridges use spanning tree to forward the packets, and routers, they use shortest path tree. So every router considers himself as a root of this tree and finds the shortest path to every other node and builds a shortest path tree, and that's how they route the data. The last application is parse tree. In compilers, we have parse tree, expression tree. These trees are used to parse your source code. Here are some more variations of trees which are used in practice. First one is trie. Trie is used to represent dictionaries. It also supports operations like prefix search. Suffix tree. Suffix tree is used to do fast searches in a string. So you have a pattern and you have a text. You have big text and you want to search different patterns in it. You can pre-process the text, build a suffix tree of it. Then you can search different patterns in this text very efficiently. The time taken by pattern search in a suffix tree is proportional to the length of the pattern, not length of the big text, which is the fastest possible way to search a pattern in a big text. The next one is binary index tree. Binary index tree is used for range query searches, and same is segment tree. Both of these trees are used for query searches within a range. Segment tree is more powerful and binary index tree is faster for a limited set of operations. So we have talked about different applications of tree data structure. Many of the variations that we've discussed here, we are going to study in the upcoming tracks. Tree is a very, very useful data structure used almost in every field of computer science. The list of applications that we've discussed here is not complete. There are many more applications of tree.